So, we were discussing with the reactor starting, and you would remember that if you use reactor starting, your starting current will be reduced only by a factor of x. I am not writing that, and starting torque will be reduced by a factor of x square, and I am comparing this with respect to direct on line start. Okay. Now, the second method is, let us do the same thing. The second method is called auto transformer starting. Auto transformer starting. In the auto transformer starting, same machine. So, delta connected I have chosen for reasons I have told you. This is the thing. What you do, you connect an auto transformer, 3-phase auto transformer, and here is your rated voltage. This is your supply bus, V rated line to line. Understood? And what you will do, you will take some from a fixed tapping here, here and here, you connect it to the machine, and here is the rotor of the machine. Okay. And so, if you apply V rated here, then depending upon where your these jockeys are, they should be ganged together. I mean, equal tappings are taken, so that the here the voltage available between the lines will be also balanced, and this voltage, once again let us assume it is reduced by a factor of x b at the machine terminals. I will assume this auto transformer to be ideal. I mean, for this large starting current, no point in taking all the I mean, considering auto transformer to be non ideal. So, this is x b here. Once again, this current, that is I starting auto in the winding, if you want to write winding, I starting, same thing here, auto winding. In this case, this will be simply x b by z s c. The magnitude of the current is important. I starting line machine, that is this current is I starting line in the machine line, not the supply line, mind you, the machine. This will be equal to root 3 times x V rated, if you are using V rated, x V rated by z s c, and this is also V rated, is not? This will be the I starting line here. Now, but the point is this current we are interested in. What is the current actually drawn from this 3-phase source? So, this I will write I starting line, supply line, it is this current. And to calculate this current in a transformer, you know, the input volt ampere is equal to output volt ampere. Equate it, you can find out, relate this current with this current. So, for the auto transformer, input volt ampere is root 3 V rated, root 3 V I is the kVA into I starting line, will be same as the output of the auto transformer, that is root 3 line to line voltage is x V rated into line current, that is I starting line machine. These two are same, and therefore, you can see I starting line will be equal to root 3 V rated goes x into I starting line machine. This will be the thing. And I starting line machine is this one. So, put it here. So, it was x here. So, root 3 x V rated by ZSC. Therefore, current drawn from the supply line current will become x square into root 3 V rated by ZSC. But this thing is nothing but the line current drawn when you adopted DOL starting. So, straight away I am writing this is equal to x square into I starting line DOL. S is a number less than 1. And what about the starting torque? Let us calculate. Starting torque will be 3 times this current square I starting winding, that is I starting auto winding phase winding current you have to take current square into R2 dashed by 1 in synchronous water, okay, R2 dashed, and this becomes equal to 3 times put this value, that is this value. So, it will be x square V rated by ZSC So, this will be this much, but 3 into V rated by ZSC squared into R2 dashed is nothing but 3 starting current DOL. Recall? This is the T starting DOL, 3 into V rated by ZSC whole square into R2 dashed. So, T starting auto transformer is this one. X square into this. Therefore, what we find in auto transformer starting, that line current drawn from the supply is reduced by a factor of x square, much less. Of course, this we also got for what is called the reactor starting. Current is reduced by a factor of x square. No, current was reduced by a factor of x in case of auto transformer starting. Now, current is reduced by a factor of x square. So, it is an improvement. However, starting torque is reduced by the same factor, that was x square also, here also it was x square, but nonetheless with respect to current you get some relief. So, you know that when we talk about the starting of 3 phase induction motor, and we compare DOL starting with auto transformer starting and that of reactor starting. With respect to DOL starting, it looks okay between auto transformer and reactor. This will be good because this reduces current by a much higher factor. Therefore, this is the thing. So, you note down that, but do not forget that in both this method you have to invest extra to purchase a reactor or auto transformer. Auto transformer is costlier than plain reactors. Therefore, you have to invest money and also you are sacrificing torque okay, by some factor x square and get some relief. But there is a nice method that is called the reactor. This was actually number 3. Now, number 4 is what is called the star delta starting. Number 4. Star delta method of starting 3-phase induction motor. In this case, and this can be, this you now note down, can be only applied if the stator, if the motor is designed for delta connected stator winding. For delta connected stator winding for normal operation. That must be understood. If you have an induction motor whose stator is star connected for its normal operation as a motor supplying load, rated voltage you apply, for that no, it is meaningless to talk about star delta starting of a star connected 3-phase induction motor. Why I am telling you? What is done is this motor is rated for idea. First let us understand very quickly, this is the normal operation delta connected, this is the cage rotor, it is like this, rated voltage is applied, no problem, normal operation, things like that. But what you can do is these 3 windings at the time of starting, what you do is this, you connect these windings in star, connect the winding stator windings in star like this. And apply rated voltage line to line, which is here V rated, this is at start. Then the applied voltage across the winding will be √3 times less. Applied voltage will be √3 times less. That is, I have neither purchased an auto transformer not an reactor. Simply at the time of starting, I will connect the windings in star, apply the full voltage, but this is not DOL starting for the machine. For the machine, DOL starting is delta connected, full voltage applied. That is why I have taken delta connected winding, which is for normal operation, and this will be this, and then once again I can calculate the starting current as well as starting torque developed. The calculation in this case is pretty simple, because I can say, if you say that this current is I starting using start delta starter line. So, I will write I starting start delta starter using start delta starter is equal to, it will be how much? It will be V rated, this pen is not good, it will be V rated by root 3 by ZSC. ZSC is the winding impedance here reflected. Getting? So, it will be just like this. In other words, this is equal to 1 by root 3 times V rated by ZSC, and what was the I starting DOL? I will write there, because I am comparing everything with that. I starting DOL was here, I starting line, here also it is line current. I starting line DOL was root 3 V rated by ZSC, is not? It was this. So, it is like V rated, well, same thing I am writing ZSC, it is like this. Therefore, I starting start delta by I starting DOL will be 1/3. This 2 will cancel, it will become 1/3. And what about T starting start delta? It will be the winding current squared into R2 dash, and winding current square is this one itself. So, V rated by root 3's current squared into R2 dash into 3 into ZSC, is not? Current square into this, and this once again will be 1/3 of T starting DOL, because T starting DOL from the previous page, you know, it was 3 by V rated by ZSC squared into R2 dash. So, take the ratio, it will become 1/3. Is that clear? Therefore, T starting start delta is 1/3 starting DOL, and T starting DO I starting start delta is 1/3 I starting DOL. This is current, this is torque. Therefore, we can say that a start delta starter is equivalent to an auto transformer starter whose setting is x equal to 1 by root 3, is not. So, start delta starting is equivalent to an auto transformer whose setting is that x small x is equal to 1 by root 3, because in an auto transformer current reduces by a factor of 1 x square, torque also reduces by a factor of x square, x in this case must be 1 by root 3, that is why it has become 1/3 and 1/3. Therefore, you see this way of starting induction motor, you do not have to invest any extra money, but at least you can get this service like an auto transformer, whose setting is small x equal to 1 by root 3. Only thing you will ask, so that a start delta starting can be implemented, is that the machine must be designed for delta connected stator in its normal operation. That is, winding rated voltage is V rated, and as delta connected it will operate like that. And second thing you will also ask for, that all the stator winding phase terminals must be available to you, because you have to make this because you connect it in start at the time of starting, then what you are going to do? Because your machine is designed for winding voltage, winding is designed for rated voltage. So, you have to do some switching, so that this star connected windings now becomes delta connected for its normal operation. Okay, at this time of starting there was some problem, large current you were talking, then you try to reduce that current by a factor of 1/3 and connect it in star. Then once again you have to go to the delta connection for normal operation. Okay. So, this point must be noted, that is, after the machine has started and speed has gone up, then once again switch over to delta connection. How this can be done? Very simply and nicely in the machine lab for small motors, it can be easily demonstrated. What you do is this: suppose you have stator windings, all the terminals now must be available to you, A1, A2, A phase or R phase, I am writing AB. This is B1, B2, stator, and this is suppose C1, C2. What I will do is this, this 3 I will connect it to supply. Here is your 3 phase supply. With few switch unit, etc. Okay. And these 6 terminals must be available to me in order to implement start delta starter. At the time of starting, what I am going to do? I will connect this A2, B2, C2 together, then it will become star. So, this can be easily achieved if you take a triple pole double throw switch. What you do? You do a little bit of wiring. So, from A2 you do this, this is triple pole double throw switch. So, A2, B2, C2 and these are the triple poles, and this side, these 3 terminals you short it like this. So, if you close it here, it will be star connected, machine is supplied. And delta connection. Achha, about delta connection you should be a bit careful, but nonetheless, if suppose 3 windings, which I am just drawing electrically, I mean how you connect. Suppose this is B1, B2 and this is C1, C2. What is delta connection of these 3 elements? Delta connection, as you know, essentially means they are connected in series and closed. So, you connect them in series, and while connecting in them in series you should be careful, finish of A phase, start of B1 and so on, and these also are closed. then it becomes delta connection. And then what you do, you from the junctions you take this 3 terminals. So, it becomes delta connected. So, delta connected, mind you, of 3 elements means they are to be connected in series and the circuit is closed. Then the junctions are the delta point junctions, that is we are drawing like this. No? I think you have got the point. So, what I will be doing on the other side of this switch, once again I will do a little bit of wiring. See, these points are the middle points. I have brought A2 here, B2 there and C2 there. Now, I know what I have to do. If I want to connect it to this side to make it a delta connection, then A2 should be connected to B1. So, I will do this wiring A2 to B1. Then B2 to C1, then I will take a piece of wire here. So, this is B1, this is C1 and finally, it must be A1, C2, A1 should be connected to C2. So, take another piece of wire, connect it here and I will write it like this. This side if you operate start and if you move this side it is run. A start delta starter can be nicely implemented provided all the 6 terminals are available, otherwise you cannot do anything. Oh, I have forgot to connect this C2 here, A2, B2 and C2 is here, is not. So, if 6 terminals are available, that means, so often induction motors with 6 terminals are available means that it is perhaps designed for delta connected operation, for normal operation, and for that machine you can exploit this method of starting, that is at the time of starting. And a rotor, of course, I have not drawn, rotor is here, rotor nothing to do with rotor. So, anyway, think about this, and if you have a small machine in the laboratory, you can easily implement start delta starting to avoid large starting current, although torque is reduced. Thank you.